Hey everyone, and welcome to This Explainer. Today, we're embarking on a super fascinating journey to uncover the scientific superpower that is quite literally woven right into the shirt on your back. We're talking about man-made fibers, or MMF. This is a massive material revolution that has completely rewritten the rules of the global fashion and textile supply chain. We're going to look way beyond just the chemistry and manufacturing today and take a really holistic look at how these engineered threads balance global economic survival, environmental health, and human innovation.
Actually, do me a favor, pause for a second, and check your shirt tag right now. I would bet good money that it says polyester, nylon, or spandex. And here's why. A staggering 70% of the entire global fiber market isn't grown in a field anymore. It's engineered in a lab. That is a massive paradigm shift from the days when human clothing relied entirely on whatever we could manage to harvest from the earth.
We've essentially fundamentally transformed the entire fashion industry, pivoting away from this ancient dependency on agriculture and fully embracing precise chemical engineering and controlled factory production. Basically, we've swapped out tractors for test tubes. This means we're no longer completely at the mercy of unpredictable weather patterns or crop failures to produce the raw materials we need to clothe a rapidly growing global population. But, this superpower certainly didn't just pop up overnight. We can actually track its rapid evolution, starting all the way back in 1892 with Hilaire de Chardonnet's artificial silk, which we know as rayon. The real game changer, though, hit in the 1930s and 40s when Wallace Carruthers invented nylon, followed pretty closely by polyester. These materials were quickly drafted for heavy-duty military use during World War II. Think of things like critical parachute gear and super durable hosiery. Fast forward to today, and these exact same synthetic foundations form the absolute core of ubiquitous modern fast fashion and high-performance technical clothing. So what exactly are we dealing with here? There are basically two main families or character classes in this material universe. First, we have regenerated cellulosic fibers, things like viscose rayon or lyocell. These actually start from a natural base, like wood pulp or plant cellulose, which gives you a really breathable, silk-like drape. On the flip side, we have the fully synthetic, non-cellulosic powerhouses like polyester, nylon, and spandex. These are born entirely from petrochemicals, granting them unbelievably high strength, elasticity, and quick drying properties.
Okay, let's dive into the step-by-step science of how this actually works. The magic happens through a process called chemical polymerization. We take those raw material inputs and chemically react them to form really long-chain polymers. These solid polymers are then melted down or dissolved into this highly viscous liquid state. Now for the coolest part. This liquid is forcefully extruded through a specialized metal plate covered in microscopic holes. It's called a spinneret. Think of it like a microscopic, extremely high-tech showerhead. As the liquid streams emerge, they instantly cool and solidify into continuous structural threads right in midair.
This incredible precision engineering is exactly what lets us customize our clothing's performance properties. By tweaking the chemical formulas and the spinning process, we can basically engineer our character's stats. We can create activewear with spandex and nylon that boasts epic stretch and rapid sweat-wicking abilities. Or we can design specialized polyester outerwear that acts as a virtually impenetrable shield against extreme weather. We can even blend these lab-made fibers with natural cotton to get the absolute best of both worlds. Now we face the ultimate land versus lab face-off, which is a really critical piece of the triple bottom line framework. While natural cotton requires massive amounts of arable land, huge water consumption, and chemical pesticides, lab-produced man-made fibers are created in entirely controlled factory environments. So from a holistic perspective, relying heavily on MMF actually frees up vital agricultural land that can be redirected toward global food security. And, that's a massive factor for densely populated regions of the world. But let's look at this totally impartially, right? Every single innovation comes with trade-offs. On one hand, MMF provides unparalleled supply stability, cost efficiency, and extreme garment durability. But on the other hand, virgin synthetic production relies super heavily on fossil fuels. Plus, we're facing the microplastic crisis, where synthetic garments shed microscopic plastic fibers during machine washing, and unfortunately, those funnel directly into our oceanic ecosystems. Taking a holistic view also means we have to examine the social dimension. This industry isn't just about machines and chemicals, it's a massive driver of human development. Transitioning to MMF creates high-skill chemical and textile engineering jobs, directly supporting UN Sustainable Development Goal 8 for decent work. There's also a big focus on consumer health safety by using skin-friendly dyes.
However, the industry has to remain incredibly vigilant regarding chemical risks. The dyeing processes for materials like viscose require strict, uncompromising management to prevent toxicity and ensure the absolute protection of both the plant workers and the consumers. Let's pivot to the business side and look at the high-stakes economic reality unfolding right now in the Bangladesh ready-made garment sector. If we look at the reality as of May 2026, a massive structural shift is aggressively underway. Shifting to man-made fibers is literally the primary engine shielding their economy. Look at the data. MMF export growth is up 14.1%, while traditional cotton performance has actually dropped by almost 6%. But here is the kicker. Synthetic production is incredibly energy intensive, and the industry is currently fighting a massive 30 to 40% spike in production energy costs. So, to navigate this energy paradox, win the global market game, and hit a jaw-dropping $100 billion export target by 2030, Bangladesh has to execute a major strategic pivot. Right now, they import the vast majority of their synthetic yarn. To survive, they need to create what's known as a backward linkage. That basically means heavy domestic investment into local polyester chip factories so they can stop a severe $3.5 billion drain on their foreign exchange. The ultimate ticking clock forcing this rapid transition is Bangladesh's upcoming least developed country graduation, scheduled for late 2026. This is a really incredible milestone, but it means losing certain protective trade preferences. Post-graduation, they are going to face 8 to 12% global tariffs. Basic cotton t-shirts simply don't have the profit margins to absorb those costs. Making the leap into high-margin, high-value MMF activewear is quite literally the only viable path to economic survival. So how do we conquer those environmental downsides we talked about earlier, like microplastics and fossil fuels? We use the 6 R's framework of the circular economy. First, redesigning, creating clothes out of monomaterials, like 100% polyester, making them infinitely easier to break down. Next, recycling, shifting aggressively away from virgin oil towards rPET, which is polyester made from recycled plastic bottles. And finally, reducing, deploying advanced AI-driven design to perfectly map out pattern cutting and massively minimize wasted fabric on the factory floor. And these material strategies build directly into global sustainability mandates. MMF is fundamentally a driver for the UN Sustainable Development Goals. It champions SDG 9 for industry and innovation by funding advanced recycling tech. It answers SDG 12 for responsible consumption by transitioning to that robust circular economy we just touched on. And it tackles SDG 13 for climate action by measurably reducing the carbon footprint, especially as mills begin integrating uninterrupted renewable energy to offset those rising power costs. The tech integration here gets even cooler. We aren't just weaving threads anymore, we are weaving data. As part of a rapid circular economy action plan, by 2027, every single MMF garment sold in Europe will require a digital product passport. By utilizing advanced digital infrastructure like RFID and blockchain, this passport is going to track a garment's exact chemical origin and its end-of-life recyclability. This leads to a crucial point. Recycling is evolving fast. The absolute holy grail commercial breakthrough that defines 2026 is chemical depolymerization. Unlike older mechanical recycling methods that just physically chop up and weaken the fibers, chemical depolymerization breaks discarded polyester all the way back down to its molecular roots, its base monomers. This incredible process allows us to infinitely recycle clothes to manufacture brand new, high-quality garments without losing a single drop of fiber strength. This ushers in what we call the hybrid paradigm, a beautiful infinity loop where performance seamlessly meets circularity. Imagine a future filled with smart textiles engineered to actively interact with the wearer, tracking your heart rate or regulating your temperature based on the weather outside. And when that futuristic garment reaches the end of its life, it goes right into a closed-loop recycling system, completely bypasses virgin petroleum extraction, and is resurrected as a brand new premium product. And the absolute next level up on this technology tree is the biosynthetic frontier. Scientists are currently engineering fibers directly from biological sources like fermented sugar, algae, and agricultural waste. The ultimate goal here is absolutely mind-blowing. An industry that creates a material that performs with the extreme engineered strength and elasticity of a synthetic, but naturally biodegrades back into the earth exactly like a fallen leaf.
So understanding these superthreads is clearly no longer just some academic exercise in textile chemistry. It is the fundamental, absolute core survival strategy of the global fashion supply chain, from shielding vital national economies like Bangladesh during major trade transitions to neutralizing global environmental impacts through closed-loop engineering. Mastering the man-made fiber life cycle is the singular, defining metric for future industry leadership. We've seen how human innovation has completely rewritten the story of what we wear, turning lab-engineered polymers into the very fabric of our modern lives. Which leaves us with this final, mind-bending thought to take away from our explainer today. If our technological innovation means that the shirt on your back can be infinitely recycled down to its raw molecular elements and reborn again and again, does the concept of waste even exist anymore?